this assignment, we're going to talk or continue our discussion on functions and talk about solving equations as well. In this example here, what we have is a graph of some function. It doesn't matter what that equation is that formed that function, but that's a graph. And we're going to use that graph to determine the graph of a function that is a translation from that. So what they've done is they've defined a new function, g of x, which is this function, f of x, plus 4. Now, if you remember from our previous discussions, f of x is the substitute for y in our earlier math understandings. So it's measured vertically. F of x is measured on the y-axis. So if I add 4 to every y value, I'm going to move up 4. So when you see an original function and then a number added or subtracted from it, it's going to move it vertically either up or down. So in this case, I want to look at this function here, this graph, and I want to try to find a graph where that has been moved up 4. And going over here, B would be my answer. In graph B, I've moved up 4. Okay? So that's the beginnings of understanding translation. Now, going from there, let's take a look at another example. In this example, they've done two things to us. Notice that from the original function, they've modified the value of x by subtracting 1 from it. And then outside the parentheses, which is outside f of x, they've subtracted 3, or added a negative 3, however you want to look at that. Well, that negative 3 is similar to the 4 in the last example, so we can say, okay, it's going to move down 3. Well, what's the negative 1 going to do? Well, the negative 1 is affecting x itself, and x is measured on the horizontal axis. So that means that I'm going to move left or right. The wrinkle in this is that when you see a number affecting x, you go the opposite direction. So instead of negative 1, which would make us think we're going to go to the left, we're actually going to go to the right 1. So in that case, I want to take the original function again, this one here, and I want to go down 3, and I want to go to the right 1, opposite the negative 1. So let's see, which one would that be? That would be C, right here. It's down 3 and right 1. All right, now let's shift subjects a little bit. Let's find the distance between a pair of points. Now there's an equation for this in the book, but I want to derive it for you so we understand where that's coming from. If I were to sketch those 2 points, it would look something like this. The point 2, 2 might be right here. And the point 11, 14 would be somewhere out here. And the distance between those points is the length of that line right there. Now, how can I find the length of that line? Well, one of the nice things about x and y is they are perpendicular to each other. X is going horizontally, y is going vertically at 90 degrees to each other. So if I go out the x-axis in this direction and up the y-axis in this direction, I will form a right triangle. And the length of the bottom of that right triangle is going from where x is 2 over to where x is 11. Well, from 2 to 11, that's a total length of 9. 2 minus 9, or 2 plus 9 is 11. Now, in the y direction, again, I'm going from y is 2 up to y is 14. That's a total length of 12. So now, what is the length of my dimension I'm looking for? Well, isn't that the hypotenuse of that right triangle? And we've learned before that there's an equation called the Pythagorean equation. A squared plus b squared equals c squared, where a and b are those two legs, or the two sides of the triangle, and c is that hypotenuse up there. Or I would say then that c is the square root of a squared plus b squared. And so in your book you've seen this equation called the distance equation, which is the square root of x2 minus x1, well that's the distance between the two x's, squared, plus y2 minus y1, that's the distance between the two y's, squared. And that's exactly the same equation as this. So that's where that comes from. Now, how are we going to solve this equation? Well, we've already determined that the difference in the x's is 9, the difference in the y's is 12, so this is the square root of 9 squared plus 12 squared, which is the square root of 81 plus 144, which is the square root of 215, I believe, which I believe that is 15 itself. So the length of that hypotenuse is equal to 15. So that's how you do that problem. So that's the distance between a pair of points. Let's look at the problem here. We want to look for the midpoint of a line segment. Now this is different than what we looked at before. Now what we want to do is find the point between 2 points, halfway between. So if I sketch it again, let's take a look at what we're talking about here. The first point is 10, 6, so I'll say that's about here. And the first point is 2, 4, which is about here. We can call that 2, 4. And we'll call this one 10, 6. And we're looking for that point right there halfway between. Well again, if you draw a right triangle, what you find is if you knew this point and this point, the two midpoints of those legs, and you drew a line up to the hypotenuse, they would come together at the midpoint of the hypotenuse. That was from geometry in high school. I don't know whether y'all remember that, but that is what that's going to do. So, what I need to do to find the x value is merely find the halfway point on the bottom and the y value, the halfway point on the side. Well, the bottom goes from 2 to 4. I'm sorry, from 2 to 10. It goes from an x of 2 to the next value of 10. If you remember the way you find that point halfway between, it's the average. Add the two together. 2 plus 10 is 12. Divided by 2 is 6. So this point right here is 6. And if I do the same thing vertically, the y's went from 4 to 6. If 4 plus 6 is 10, half of that is 5. I think you can see 5, of course, is halfway between 4 and 6. So this point that we're looking for here then is the point 6, 5. So how do we show that mathematically? What we do is we say that the midpoint is equal to x1 plus x2 over 2, comma, y1 plus y2 over 2. We added them together and divided by 2. That gives us the 2 points. And of course, this is described as a coordinate pair now, x comma y. And that'll give you then the midpoint. Now, number 11 says solve the equation. Well, what we want to do is we want to remember our order of operations here. And some people remember that by the little saying, please excuse my dear Aunt Sally. The way I like to show that is, please excuse my dear Aunt Sally. Now, the reason that I put M and D and A and S on the same line is because in an earlier discussion I told you there is no division, there is no subtraction. Those are actually components of multiplication and addition. Therefore, I need to do multiplication and division and addition and subtraction in the same way. But we have a convention for that. We work from left to right when we do them. So, in this equation, I see a parentheses. So I want to look inside that parentheses and say, can I do anything? That parentheses is 3x minus 4. That's what's inside the parentheses. Can I simplify 3x minus 4? No. They're two unlike terms. It's an x term and a constant term. Cannot combine those. So now I must go outside the parentheses. Well, E is for exponents. Do we have any exponents? No, no exponents. How about multiplication and division? Well, on the left-hand side there, you'll notice that there's a negative in front of that parentheses. That's like saying negative 1 times that parentheses. So if I multiply or distribute that negative 1 across the parentheses, that could be my, or should be my next step. So let's do that. So I'll keep the 5x where it is. But now negative 1 times a 3x is negative 3x. And negative 1 times a negative 4 is positive 4. And that still equals 12. Now before we move anything across the equal sign, I want to combine like terms over here. The 5x minus 3x is 2x. Now, let's move the 4. To move a positive 4, I want to add a negative 4. So this is going to be 2x is equal to 12 minus 4, or 2x is equal to 8. Now we want to move the 2. It's multiplying the x, so we want to divide by 2. And x then would equal 4. And that would be your solution to that problem. What do we do when we have fractions involved and different terms? Well, in this case, what I recommend you always do is find the common denominator and put it under every term, including that negative 15 there. So our lowest common denominator for 5 and 6 is 30. So what we're going to do is put 30 under each one of those. So I have a fraction on the left, and I want a 30 under it, equals, but I have two terms with a minus in the middle on the right, so I'm going to put a 30 under each one of those. Now, what did I do on the left? You go from 5 to 30. I multiply by 6. If I multiply the denominator by 6, I need to also multiply the numerator by 6, or I've changed the value, and I don't want to change the value, I just want to change what it looks like. So there's a 6 on top. On the right-hand side, where I did have x over 6, I'm now over 30. To go from 6 to 30, I multiplied by 5. So I need to multiply the top by 5. And that 15 was understood to be over 1, because it's a whole number. So I multiplied by 30. So 30 times 15 is 450. Now I can combine the right-hand side. So 6x over 30 is equal to 5x minus 450 all over 30. Now that I have both sides over 30, if I were to multiply both sides of the equation by 30, those denominators would cancel out. And now I don't have fractions anymore. I have 6x equals 5x minus 450. Subtract 5x from both sides, and I'll have x is equal to negative 450. So that was number 12. Let's look at number 13. Now, using that same principle here is going to save us from something. This is one that students have a lot of trouble with, and it is because of that negative in front of that second fraction. That negative means that whole fraction's negative, and if I'm not careful, I'll end up losing that, that realization, and I'll end up putting that negative on just the first value, x, instead of that whole expression. So what I'm going to do is what I did last time. I'm not going to try to put anything together yet. I'm going to find a common denominator. And the common denominator here is 6. So I want to put a 6 under everything. On the left, I have one fraction, so I'm going to put a 6 under it. On the right, I have two terms. Put a 6 under the first one, minus a 6 under the second. Now on the left-hand side, I had a 3, I now have a 6. That means I multiplied by 2. So I multiply the top by 2. On the right-hand side, the 3 was over a 1. The whole number 3 was over a 1. So I multiplied by 6. So when I multiply the top by 6, I'll get 18. In the second one, second term, the denominator was a 2, now it's a 6, that means I multiplied by 3. Now I can put it all together. So 2 x plus 1 over 6 is equal to 18 over 18 minus 3 times x plus 3, all over 6. And now that negative sign is in front of the 3, and I will hopefully know that I need to distribute a negative 3 across that parentheses with x plus 3 in it. And now I'll get things right. But first, before I do that, I'm going to multiply both sides by 6 and get rid of my denominators. And now it becomes even clearer what I need to do next. So let's go ahead and distribute. On the left-hand side, I'll get 2x plus 2 equals 18. Now this is a negative 3 I'm distributing, so it's negative 3x. Negative 3 times a negative 3 times a positive 3 is negative 9. So 2x plus 2. I have an 18 and a negative 9. That leaves me with a 9 minus 3x. Now, let's put all of the x terms on the left and the constants on the right. So I'm going to move the negative 3x I'll add it. When I add it, I'll get 5x. I'll subtract the 2 from both sides and get a 7. Now I need to move the 5. It's multiplying the x, so I divide. And x is equal to 7/5. Okay, now let's try some rather simple word problems, but they are word problems. So when we are given a sentence like this, how are we going to convert that into an equation so we can solve it? It says when a number is decreased by 20% of itself, the result is 56. Now the result is an equal sign. So I know that 56 is going to go on the other side of an equal sign. But what does it mean to say a number is decreased by 20% of itself? Well, first of all, in equations we don't use percents, we use the decimal equivalent. So 20% is 0.20. So let's see if we can write that out. Let's use x for our number. We often do that when the number is unknown. So x is decreased. We're going to subtract something from it. What are we subtracting from it? We're subtracting 0.20 times it. In other words, when a number is decreased by 20% of itself, of means times, of itself, the result is 56. Well, that x is 1x. So 1 minus 0.20. Well, if you take 20% of something away, what do you have left? You have 80%. So it's 0.80. Now we need to move the 0.80. So x is equal to 7. Okay? So let's take a look at this last one here. One number exceeds another by 9. The sum of the numbers is 51. What are the numbers? Well, in a lot of the cases where you've seen these before, you've used x and y. But, you know, if one number exceeds another by 9, then one of the numbers is x and the other is x plus 9. So we don't have to use a y. We can say that our two numbers are x and x plus 9. Because one number exceeds the other by 9. When I add those together, I get 51. So that's x plus 9 is equal to 51. But that's 2 x's plus 9 is equal to 51. Or 2x is equal to 42, or x is equal to 21, and the other number now, don't forget that, is equal to 21 plus 9 is 30. So the numbers are 21 and 30. So hopefully I've given you enough that you can go back and do this homework now and use these methods to solve these problems.